Since its establishment, FPC has encouraged its employees to accumulate rich professional capabilities and development experience in raw materials, product manufacturing, and processing applications through an industry vertical integration model. Built in 1986, the Renru plant initially manufactured carbon fiber with an annual production capacity of 750 tons. To cope with the Mailiao plant expansion in 1999, the facilities at Renru plant were gradually shifted to Mailiao and recorded an annual capacity of 3,950 tons of carbon fiber. Following an increase in market demand, the Mailiao plant started to increase the production of carbon fiber in 2008 to achieve an annual capacity of 8,750 tons. Currently, all FPC carbon fiber products are manufactured within the Mailiao plant premises. Besides self-supplying raw materials for the carbon fiber plant within the Mailiao premises, the Renru plant is still planning to produce and supply precursor to the carbon fiber plant within Mailiao premises. After the raw material has gone through formulation, polymerization, and spinning processes, it is followed by semi-finished product packaging by an advanced winder to prepare for the next stage of carbonization. This highly sophisticated winder is able to perform automatic weight calculations and automatic transportation of precursor to the automated storage and retrieval system. Each semi-finished precursor is controlled and labeled by the computer to establish a production resume to ease tracking the production process and ensure stable production quality. The semi-finished precursor is then immediately transferred and stored in the automated storage and retrieval system to wait for production arrangements to be made into carbon fiber. After the production line has been arranged, the automated storage and retrieval system will then perform automatic precursor refiling in creels according to the production schedule to complete all the preparatory works of the carbon fiber production. The operator only needs to enter the schedule in the computer, and the automatic precursor refiling system will perform semi-finished precursor refilling with robotic arm. Such processes are meant to ensure effective precursor refilling quantity and quality and reduce manual operations significantly. Oxidation and carbonization are the most important production processes of carbon fiber sintering, being currently processed by the world's most advanced and sophisticated equipment. Then the semi-finished precursor will undergo gradual carbonization under different ambient temperatures. Automated control systems are adopted throughout the production process by all equipment to strive for quality uniformity. A most advanced winder is used in the packaging section to ensure the uniformity of each carbon fiber finished product. It is capable of conducting automatic counting and automatic retrieval operations to achieve high product homogeneity. FPC Terryfill is made from pan-based raw material and is currently able to provide carbon fiber for use in sports and recreation industries, civil engineering and reinforcement industries, and special industries such as wind power electric generation, cable cores, high-pressure gas vessels, etc. Carbon fiber can be subdivided into general modulus, intermediate modulus, and high modulus specifications. The cooling tower is a heat rejection device that ejects waste heat to the atmosphere through the cooling of a water stream to a lower temperature. With FPC TC35R 24K carbon fiber for the light and stiffiness material for the blade of the cooling tower, the high modulus property of CFRP reduces the bending of the blade and thus decreases the turbulence induced during rotation. This results in a 10% increase of cooling efficiency over long-term use. Increased volatility in oil prices and a growing recognition of the human contribution to global warming and environmental pollution. FPC TC33 and TC35R carbon fiber would be of the greatest use in automobiles, as they have a very high strength-to-weight ratio and are essentially carbon fiber bounded by polymers such as epoxy resin. The density is as low as 1.6 gram per cc, which makes it extremely lightweight as opposed to steel, without compromising on strength. Wind is an increasingly important source of renewable energy, especially offshore turbines with FPC TC35R 24K and 48K carbon fiber, are moving quickly from 3 megawatts to next-generation turbines rated at 10 megawatts and larger, on which blade lengths for both on- and offshore systems regularly exceed 80 meters. As blades grow longer, the idea is to convert structural areas of the blade from E-glass to significantly stiffer and lighter carbon fiber to decrease the turbulence induced during rotating and increase the power generation efficiency. By replacing steel cord cables with composite cord cables, the ACCC cable with FPC TC36P 12K carbon fiber can operate at a higher current level and push more power, double the current carrying capacity, through the system without risk of sag and disruption of service. In new construction, composites' high strength to weight and low sag translate to longer spans between towers, reducing the number of towers needed to carry the electrical load by 16%. The evolution of vessels and tanks designed to hold liquids and gases under pressure has proceeded through 4 distinct stages. FPC TC36P 12K carbon fiber has been at the forefront of the evolution of high-pressure vessels and tanks for many years. The benefits of carbon fiber as a lightweight alternative to other material makes, combined with its durability and corrosion resistance properties, have been driving innovation in these applications for decades. Carbon fiber is often seen as the dream material of cycling. When well produced, it's light and stiff, with FPC TC42S 12K and 24K carbon fiber. Most brands come up with fancy-sounding titles for their own carbon construction. However, the vast majority of the raw carbon fiber actually comes just from FPC, which is located in Taiwan and near most of the manufacturers. It's how the material is manipulated by the bike brand which influences the ride quality and strength. After the optimization of process, the tensile strength of regular modulus TC36S is around 725 kSi. The variation of tensile strength is lower than 3.5%, and the variation of 0-degree composite strength is lower than 5.0%. The tensile strength of intermediate modulus TC42S is around 800 kSi or more. The variation of tensile strength is lower than 3.5%, and the variation of 0-degree composite strength is lower than 5.0%. FPC Terrafill carbon fiber can meet the production needs of various composite carbon fiber materials, including applications for sports, industry, aerospace, and other domains. In order to elevate the quality of customer service and integrate with a downstream application, the company takes Renwu plant as an R&D base for carbon fiber composites to implement a series of manufacturing for carbon fiber prepreg, molding for carbon fiber composites, and inspection for carbon fiber composites to ensure the quality of carbon fiber and assist in developing the relevant application of composites material. In order to reflect the company's operating mode in its vertical integration and make the carbon fiber product closer to the customer's needs, as well as develop its application in the field of aerospace, it specially established a plant for the carbon fiber prepreg, which could manufacture their own prepreg in the width of 1 meter to serve the customers or improve the feedback on the quality of carbon fiber. The production process for the prepreg plant could be divided into 2 sections, coating and impregnation. In the coating section, it produces the semi-finished product of resin film. In the impregnation section, it produces the finished product of prepreg of carbon fiber. The process in the coating section includes the coating rollers, inspection for the thickness of resin film and cooling, as well as the semi-finished product winding unit of resin film to apply in its later impregnation section. The impregnation section is to produce the finished product of prepreg. Its processes include the creels, tension bars, impregnation for resin film and double sides, heating rolls and plates, cold air cooling, as well as the inspection for the prepreg surface and product winding units. The Laboratory for Carbon Fiber Composites continues to make the carbon fiber prepreg be the test piece of carbon fiber composites in applying in the next stage of physical test. Its main process includes the automatic prepreg cutting, laminating for prepreg, molding for composites, cutting for composites. After submitting the finished product of prepreg to the Laboratory of Carbon Fiber Composites, it implements the automatic prepreg cutting according to the specification required for the convenience of later needs from the molding equipment. For the completed prepreg cutting, it follows their folding sequence and thickness for implementing the accurate laminating of prepreg. Following the characteristics of different prepregs, implement the molding of composites. The molding plant for composites is equipped with a vacuum hot presser of outstanding function, which could effectively reduce the defects after the molding for composites. After the completion of molding, the composites are cut to the sizes necessary for testing by the precision cutting of CNC Composites cutter, which could achieve the tolerance of test piece required by the relevant international inspection practice to reduce the damage from the cutting of the test piece. In order to ensure that the inspection method for each specification of carbon fiber composites is in compliance with international inspection practices, the company purchased the most advanced 10-ton grade universal testing machine. Its inspection items includes the testing on the physical specification of carbon fiber composites like the tensile test, compression test, in-plane shear test, and interlaminar shear test, etc. The machine for material testing is also equipped with the environmental test chamber with precise control. Its above-mentioned specifications could be tested in high and low temperatures to satisfy the customer's special requirements. At the same time, it is also an indispensable critical tool in the high-end field of aerospace development, etc.